let us see the combination of pipes in this video. These pipes can be connected in series, these pipes can be connected in parallel according to our use. So pipes in series. So series means, so here there is one pipe and it is this end is connected with this pipe, this end is connected with this pipe. So this is called as series arrangement. In case of parallel, one single pipe is divided into two or more branches, that is called as parallel pipes, and two or more pipes are joined to one single pipe, that is also parallel joint. So let us see pipes in series first. Okay, so this is, let me say this is pipe 1, this is pipe 2, pipe 3. This pipe 1 has length L1 and pipe 2 has length L2 and pipe 3 has length L3. So what about the discharge? Discharge will be constant. Since this is only since the only cross section area of this pipe is changing, and discharge will be constant when there is only one flow and there is no branched flows. So the fluid is not distributing to another pipes, only fluid is flowing in that pipe only, but that is of different cross sections. So discharge will be constant, that will be area into velocity is constant. When area decreases, velocity increases. When area increases, velocity decreases. That is how the discharge is maintained constant in series pipes. So here Q1 discharge in pipe 1 is equal to discharge in pipe 2 is equal to discharge in pipe 3. So then what about head loss? Head loss, HF. What is head loss? Here the pressure is P1. Let me say here the pressure is P2. So there will be a head loss. Here the pressure will be P3. There is a pressure difference and this there is a head loss. So there will be different head losses for different pipes, since the pressure differences are different at different lengths. So HF is equal to FLV square by 2GD. So here for first pipe HF1, that will be FL1 V1 square by 2G D1. This can also be written as FLQ square by 2GD. In this case, this is L1, this is Q1, Q1, Q2, Q3. All are equal, so I am writing it as Q. So FLQ squared by 2G D1. So D1 is diameter of this pipe 1. Similarly, this is D2 and this is D3. So that is HF1. So here there is HF1, here there is HF2 head loss, here there is HF3 head loss. So total HF head loss of from here to here, there is a pressure P1 and here let me say this is pressure final. So there is a pressure drop and that total pressure drop is equal to HF, which is equal to P1 minus PF divided by rho G. So HF is equal to F L1 Q square divided by 2G D1 plus F L2 Q square divided by 2G D2 2G D2 plus F L3 Q square divided by 2G D3. So here Q is constant and that's why I wrote Q, and F will be constant since it depends on Reynolds number. So F is constant. So this is what total head loss for the series connection. And if we need to replace this pipe with a single pipe, so if I need to replace with a single pipe having same pressure loss, which means here P1 is present and here PF should be present. So how much length should be maintained? This is called, I am calling it as equivalent pipe. So this is equivalent length and this is equivalent diameter. So how to find that? Simple. In the place of HF, put the formula FLQ square divided by 2GD. So we are considering only a single pipe which gives us the same head loss. That will be FLEQ square divided by 2GDE. So this is equivalent length and this is equivalent diameter. That will be equal to, so I am taking here common FQ square divided by 2G as common, and L1 by D1 plus L2 by D2 plus L3 by D3. So now F gets cancelled, Q square, 2G. So finally the remaining is, sorry, I wrote the formula wrong here. This is FLQ square divided by 12 D1 power 5, and here so here also 12 D1 power 5, 12 D2 power 5 and 12 D3 power 5. And here also 12 DE power 5. So FQ square divided by 12. So just 12, that's it. Taking this common, here D1 power 5, D2 power 5 and D3 power 5. So here 12 gets cancelled, and the finally remaining is LE divided by DE power 5 is equal to L1 by D1 power 5 plus L2 by D2 power 5 plus L3 by D3 power 5. So from this we can find the equivalent length and equivalent diameter. So if you need to convert this pipe into, if I ask in a question, you need to maintain some diameter 20 centimeter. So how much length should be maintained so that the head loss will be same in this case and this one? So how much length should be maintained? From this we can find it. Now we will see pipes in parallel. In pipes in parallel, the fluid is divided into branches. So if Q comes from here, Q1 is divided here and Q2, and again they are joined and discharge will be same here. So Q1 and Q2 will be distributed if there are two branches. In this case, Q is equal to Q1 plus Q2. And what will be the head loss? Head loss is equal to what? You can see here the pressure that may exist is only one pressure can exist. Two pressures cannot exist at this junction. Let me say here there is pressure P1 and at this junction there is pressure P2. So what is head loss? Is equal to P1 minus P2 by rho g. So if any branches are there but the pressure is only P1 minus P2 by rho g. So there may be number of branches, any number of branches, but the pressure is the pressure drop is P1 minus P2 and head loss will be P1 minus P2 by rho g. So that will be constant. So HF1 is equal to HF2 is equal to P1 minus P2 by rho g. So head loss will be constant. So HF is equal to F L1 I'm writing in terms of Q. F L1 Q1 square divided by 12 D1 power 5, which is equal to F L2 Q square Q2 square divided by 12 D2 power 5. So from this, what you can write, so these are equal, and Q1 plus Q2, Q is equal to Q1 plus Q2. So from this we can write F LE Q square divided by 12 D power 5 DE power 5. I am converting this parallel connection into a single pipe of diameter DE, equivalent diameter and equivalent length. That will be, this is equal to HF. So Q can be written as HF into 12 DE power 5 divided by F into LE, that is equal to Q square. So under root will give us Q. So Q is equal to HF into 12 DE power 5 divided by F into LE under root. So what is Q1? Under root of HF1, HF2 are equal, and that is equal to HF. So HF into 12 D1 power 5 divided by F into L1. So plus under root of HF into 12 D2 power 5 divided by F into L2. So taking the common terms outside, under root of HF into 12 divided by F into under root of DE power 5 divided by LE is equal to under root of HF into 12 divided by F, taking this common, and inside D1 power 5 divided by L1 plus D2 power 5 divided by L2. So cancelling this, under root of DE power 5 divided by LE is equal to under root of D1 power 5 divided by L1 plus under root of D2 power 5 divided by L2. So here there are two branches and we got it as two terms. If there are three branches, and another term will be added here, under root of D3 power 5 by L3. So this is the equivalent length and equivalent diameter for parallel connection. This is about series and parallel connections.